Okay, C. Lindelof videos, AP Calculus, a chain rule problem that's attached to a product rule problem, if you will. So we're just going to kind of pick our way through this a little bit. It says, find y prime, find the first derivative of y, given that y is equal to 1/2 x squared times the square root of 16 minus x squared. So I'm just going to start out this way. I'm going to start looking at this in two different ways. I know that a square root is the same as a 1/2 power. So I'm going to set this up as a 1/2 power here, if that's okay with you. I haven't done any calculus at all yet. I'm just looking at this algebraically, and then I'm going to start getting my pieces together. It's this function right here times this one. So that's kind of a product rule problem. So what I'm going to do is I'm just going to start my list and say, okay, f of x is equal to 1/2 x squared. F prime at x is equal to 2 times 1/2 is 1. Decrement this by 1 is just x, isn't it? And then g of x is equal to 16 minus x squared to the 1/2 power. Here's where the chain rule part comes in. So I want to show you this. This is chain rule here. This is a chain rule problem. Because when we look at this function, this inner function here, we can see that this inner function is composite of this outer piece in yellow here and the inner piece here. So what I'm going to do is I'm just going to look at it like this and say, okay, what is the derivative of this part that's in orange? Well, the derivative of the part that's in orange, which is going to be my g prime at x, will be 1/2, right? I'm just taking the derivative of this orange part. So 1/2 times this is 1/2. The stuff on the inside, I'm just going to leave it alone, if that's okay with you. And then remember, I have to decrement this, so you have to reduce this by 1, so 1/2 minus 2/2, 2/2 is 1, is negative 1/2, isn't it? And then what you're supposed to do, given the chain rule, is that you're supposed to put this piece in here back in, right? Put this piece in here back in. And then you take the derivative of the inside piece. Well, the derivative of 16 minus x squared is negative 2x, right? So now I have all my pieces in place. So I look at this, I'm like, this is a product rule problem, but I realized that when I got to this mess right here, I was going to have to use the chain rule to sort this out. So I think I have to sort it out pretty well, so I'm going to start putting it together. And I'm going to say that my y prime is equal to, and if you remember, the product rule says it's f of x times g prime, so 1/2 x squared times this g prime at x. Look at this for a second. 1/2 times negative 2 is negative 1, isn't it? And negative 1 times x is negative x. So negative x times 16 minus square root to the negative 1/2. Holy crap, I'm running out of room here. You know, let me just move this down. So y prime is equal to 1/2 x squared times x times 16 minus x squared to the negative 1/2 power, right? Plus, we're supposed to take g of x, which was 16 minus x squared, remember it was to the 1/2 power, times f prime at x, times the derivative of the outside piece, and the derivative of the outside piece is just x, isn't it? Here we're kind of done. Of course, they're not going to let us stop if you're taking the AP exam. They're not going to let us stop. But one thing I can see is this. 1/2 times x squared is the same as x squared over 2, isn't it? And I can rewrite this to say this. I have x squared over 2, that's just me cleaning this crap up, times, right? This has a negative exponent. We cure negative exponents by bringing them to the bottom, so this becomes 16 minus x squared to the positive 1/2 power, doesn't it? And this negative x goes to the top here. Does that make sense? Plus 16 minus x squared to the 1/2 times x. Remember, we can't distribute this x inside of that, right? So I'm just going to start putting this crap together. And I do x squared times negative x is negative x cubed, isn't it? Over 2 times this crap is 2 times that crap, which is 16 minus x squared to the 1/2, isn't it? Just to make this work, because what I'd like to do is get all of this under one denominator, over one denominator. So what I'm going to do here is this. This is this whole thing over 1, isn't it? But if you look at the denominator of this left-hand side, it's this, isn't it? So that's what I'm going to do. I'm going to take this denominator right here, and I'm going to multiply it by that. Say, look, it's right here. It is 2 times 16 minus x squared to the 1/2 over 2 16 minus x squared to the 1/2, right? It's a lot of crap going on here, but remember, this is 1/2 power. Remember, if we multiply this 1/2 power times this 1/2 power, they cancel each other, don't they? They don't cancel each other. This to the 1/2 times this to the 1/2 is this to the 1/2 plus 1/2, which is just 1, isn't it? So 2 times x is 2x, so plus 2x times 16 minus x squared, right? Now our denominators match. Hopefully you can see that. And then as I finish all this math up, I'm just going to clean it up now and say that y prime is equal to negative x cubed plus 2x times 16 is 32x, isn't it? 2x times negative x squared is negative 2x cubed, isn't it? All over 2 times 16 minus x squared to the 1/2 power. If you were doing this on free response, I probably wouldn't go this much out. But if you're doing this on the multiple choice part, dude, you're gonna have to grind through all this algebra. So you're just gonna have to keep going. Negative x cubed minus 2x cubed is negative 3x cubed, isn't it? 3x cubed plus 32x all over 2. Remember, we cannot distribute that 2 because we have this thing here, don't we? And here's my y prime. Look, this is really difficult. It's a lot of stuff. Let me say this to you. The more you get used to this, the more of these problems that you do, the more you'll get it. And all of a sudden you're going to be like, oh my God, this is making really good sense. Until then, man, fight on, because you can definitely do this, all right? If you have any comments, please make them. If you have a question or anything, I'd love to hear them. And thanks for your support. If you haven't already subscribed, please do. Thanks.